And like Waleed said, I'm providing maybe a little bit of an addendum to the remote sensing talks that we've heard about this week. I'll be talking about how we are collecting data only on the ground at subnational scales and what that means for connections with remote sensing and what it can bring to us. Um, and so HarvestStat is this consortium-led project across 15 institutions, and we're really trying to collect all the subnational data in the world. And so I'll get into exactly what that means and what that looks like through this presentation. But just to kind of provide a roadmap for what we'll be doing, we're first going to kind of go through the motivation. Why do we care about subnational data at all? I'll introduce kind of HarvestStat and what HarvestStat can bring to the table. I'll go into how we've split up HarvestStat. So we are tackling this project regionally just because it's kind of a massive undertaking. And so I'll highlight regional data sets that have just been completed, ones that are in progress, and the ones we have planned to tackle shortly. And I'll highlight some of the kind of preliminary science results. Most of HarvestStat's goal is to just deliver the data so that people can do amazing science with it. So these are kind of just more examples of what can be done with this subnational data, the possibilities it opens up. And so hopefully it can spark kind of interest in using this data for your own science. And then finally, I will just talk about planned projects coming up in the HarvestStat ecosystem, things to look out for over the next year or so. Okay, so I first want to start off with mapping food production. And so we've heard a lot about remote sensing approaches to do this. And on the right is a pretty incredible product that came out recently called Crop Grids that produces cropland maps for 173 crops. Um, my background is in astronomy, and I switched over to this field recently. I did not know there were 173 crops, but it turns out there are. And so this is a pretty incredible product um, that's made possible by kind of remote sensing approaches. And modern data collection methods for understanding where food is produced include satellite inference, government reported data, and even AI image recognition. There's work being done, even taking images from the cars that drive around and make the maps for Google. You can actually take the images taken by those cars, ask a neural network kind of like what looks like crops, and you can map out uh, fields that way, which is kind of a cool way to get at smallholder farms in areas that might otherwise be kind of inaccessible. So there's a lot of methods now for trying to understand where crops are grown. But it's important to keep in mind that almost all of the farms globally are smallholder farms. The Food and Agriculture Organization estimates that 5 out of 6 are less than 2 acres. So any of the data collection methods we use needs to take into account that most of the ways people engage with agriculture are done on a smaller scale, not with the larger scale factory farms. And so when we start thinking about the data that's present from governments, um, unfortunately, a lot of it is mostly available at national scales, which makes it tricky to kind of reconcile the data we have on the ground with the satellite retrievals that can actually get down to the smallholder farm scales. So what I'm showing on the right is data that comes from FAO. It's part of their FAO stat product, which is national data collected directly from reporting countries. So the United Nations has agreements with countries to receive agricultural statistics when they're produced in that country, and then they make this available to the public for free through this FAO stat data product, which is great. It's provided a huge wealth of information, led to countless studies, but it's only at the national level. FAO would like to move to the subnational level, but that infrastructure is not built out yet. So this is kind of our best knowledge so far on a global scale. And so a few limitations here, even beyond the fact it's just at national level, is that FAO relies on agricultural census information collected by the country. They are not necessarily going out into the fields asking people where crops are being grown, how much is being produced each year. They're relying on governments and statistical bureaus to do that work. And a number of countries don't regularly produce a national agricultural census. So on the left is a plot from a recent kind of review of the field by Andy Kadebe at University of Delaware. Highly recommend checking out this work for kind of a overview of where the field is at right now. But we can see, especially in sub-Saharan Africa, there are a lot of places where there just aren't publicly available standard agricultural census information. And this is a real limitation to the FAO stat data product because they're just relying on kind of what governments give to them. And so if the government is not providing something, we might not have access to that in the FAO stat database. Lots of countries also have higher resolution data than national. So if we look at the bottom plot here, the dark green countries have district level data potentially available, and then the light green countries have province or state level available. So there's a lot of information out there that's not captured in the FAO stat data, which suggests to us that there's a lot of potential if someone were to go out and gather all the subnational data. There's a lot we're missing right now. And so that's the motivation for HarvestStat. To take it even a bit further, I wanted to highlight the drawbacks of using kind of the existing data with some of these gridded products. And so on the bottom here, we're looking at how we would measure the change in maize yields throughout a few countries in sub-Saharan Africa from 2000 to 2005. And the colors just show percentage change in yield. On the right is true subnational data. This is part of the HarvestStat Africa regional data set that I'll get into more later. But this is our best guess of what's actually happening on the ground. The two products on the left are two incredible data sets, widely used, widely cited, that use gridded data, including remote sensing information, and build in crop statistics, but without using the actual like subnational statistics, using only isolated groups of subnational statistics, or in some cases, just downsampling a national statistic. We can see we get a very different answer here by not using all of the true subnational statistics. And the reason that they just haven't been made available yet is because it's hard to collect. It's a very hard undertaking. And so I'll get into a little bit why I think there are a few bottlenecks and how we're trying to solve them. So we've kind of covered why we need subnational data. If we just look at national data, we're not getting the resolution we need, especially to compare to satellite retrievals. And in an ideal world, we'd probably be able to just observe everything with satellites. So we have real-time estimation of how food is growing at really high resolution. To get closer to that, we need higher resolution ground truth data. Subnational statistics also provide a point of validation with the national statistics. So I was kind of surprised to learn by doing this work that the national statistics do not necessarily represent just the sum of the subnational statistics. So we found a large number of cases where if you take the subnational statistics for a particular crop in a particular year and you add them all up, it does not equal the national statistic number that FAO stat provides. And a lot of times this is because the national number represents more of an estimate, or there might be nuances in the subnational data collection that try to be more accurate, but end up getting farther from the answer. So we don't necessarily know whether the subnational or the national data is more accurate a priori, but we have another point of validation here. Um, and so all of this leads us to HarvestStat, which is a global effort to assemble all of the existing government reported subnational crop statistics and produce a freely available data set. So everything we talk about is going to be made public, freely available, totally open source. And so we're pretty excited about that. The reason we're able to do this is because of the incredible work done by the Famine Early Warning Systems Network, or FuseNet, which has 40 years of experience monitoring food insecurity. They've collected a lot of these subnational statistics that aren't kind of available online just through connections they have in countries or through keeping track of records that might not be published anymore. Um, they've managed to assemble a pretty impressive amount of statistics globally, but they haven't published a lot of it. So for every country, we have kind of a decent starting point just because of the work that FuseNet has done. And then we're building off of that. We're trying to fill in any gaps that exist in their data collection. And our consortium beyond FuseNet represents 15 institutions all across the world. And so we're trying to make this as global and helpful for people everywhere as we possibly can. If you're interested in more details than I covered today, I would encourage you to check out kind of our vision paper that highlights our procedures and our goals for the data set in a paper by Kyle Davis from this year in Environmental Research Letters. Yeah, and happy to chat more about any details later on too. So the current leadership team is shown here. Weston Anderson, who folks at Maryland might know, is one of the people spearheading the effort. And we have a lot of representation from all over the world here, including a lot of folks who have been responsible for building the big, highly cited gridded data products, who are lending their expertise to our subnational data collection. So we're ensuring that what we put out is ready to be incorporated into models that rely on remote sensing retrievals as well, and so it can work well with existing data sets or work that folks would like to do in the future. So to highlight the scope here, because I've said we want to collect all the data ever produced anyway, we are kind of setting our scope to be, we would like to get subnational statistics from 1980 or as far back as possible to present at administrative level 2 or the finest resolution possible in each country. Administrative level 2 would be like the county equivalent in the US. And so administrative level 1 would be state or province. In a lot of countries, we won't have access to administrative level 2 data. It's just not collected. Or for countries that have a smaller geographical footprint, sometimes there just isn't an administrative level 2 that has a meaningful designation. And so we can't get to this in every country, but this is kind of our goal. So in countries that provide more detail, we're not going to necessarily go beyond administrative level 2 or far beyond 1980, unless the statistics are just kind of flying there. For example, in Japan, we're back to the 1800s just because of incredible records there. We're collecting all crops that are available, but we're prioritizing staple and cash crops, the ones more important for food security and economic impacts. But if other crops are available, we include that in our data set as well. We are then standardizing everything using the FuseNet framework, which has been kind of in place for decades now. It's proven to be really useful and include kind of all the information necessary to use this data to assess food insecurity. And all of this standardization and the code to do so will be made public as well. And then, like I said, we're tackling this in regional chunks. And so HarvestStat Africa is already complete. This is work led by Dong-Hoon Lee that was published this year, and it represents uh, um, assemblage of the incredible amount of work that FuseNet has done in sub-Saharan Africa, and it includes a lot of the countries that we saw in the earlier map didn't necessarily have consistent agricultural censuses. So this represents incredible wealth of information that hadn't necessarily been made public before. In progress right now, I'm leading the data set looking at South and Southeastern Asia. That'll be 20 countries there, including China and India, that I will get into a bit more later. We have the Middle East and North Africa that is spinning up, thanks to great work by people like Walid. And then we have Latin America and the Caribbean that is also spinning up. And then our upcoming data sets will be Central Asia, Europe, and North America over the course of the next 1 to 2 years, depending on how quickly the other data sets proceed. So you might wonder, why hasn't this been done yet? Why are all these statistics sitting out there still waiting to be collected? And I think it's two main reasons. One, a lot of these statistics, especially the ones prior to 2000, have not been digitized yet. A lot of the data we're finding is in old published agricultural yearbooks that still needs to be digitized. And for some countries, we've actually taken our digital data and shared it back with them because they didn't have digital access to it. And so a lot of these statistics are just kind of sitting around. They needed to be digitized, or they were not present in English, and we're trying to put everything in English for our data set. And they needed a lot of standardization. And so it's only recently that AI has kind of made this possible at scale, because now we can take a lot of these records that haven't been digitized and get digital versions much more easily than just sitting there and kind of typing it out by hand. The other main reason is boundaries. So when we're working at subnational scales, we have to contend with administrative unit shifts over time. And for some countries, this can be really substantial. So for India, for example, we have data at administrative level 2, the district level. India has had thousands of district changes over the course of our data collection. And we need to map kind of every single one of those to ensure that the statistics that we're reporting are accurate. Because if a statistic is only provided with the name of a district, we don't necessarily have a map ahead of time. And we don't necessarily have a map of the country at every point in time that there is an administrative unit change. So what that means is that we need to kind of reverse engineer the boundaries of each country in order to accurately report these statistics. And that takes a lot of time, only kind of possible because Fuse has already given us a leg up by doing a lot of this work in a number of the countries. And so we're kind of filling that out as well. But yeah, to just put that in a little bit more context. So in Africa, half of the countries have increased their number of subnational administrative units by over 20% within the past few decades. And in India, it's more than doubled. And this information is not available in a nice tabular machine readable format kind of anywhere. We're going onto Wikipedia. Wikipedia is actually proven to be one of the best sources for this information because it's crowdsourced and it's actually kept up to date. So but it's a lot of manual identification of administrative shifts. So I think those are the two main reasons this has not been done yet, but two reasons we're excited to push this out now because we think it'll be useful. So just to really shine more of a spotlight on FuseNet, they're an initiative of USAID that has now been moved into the US Department of State. They've been collecting data on food insecurity for 40 years now, mainly focusing in sub-Saharan Africa, but they've expanded to Central Asia and then Central America, but then also are starting to monitor a few countries in Central Asia. And they have lots of on-the-ground contacts who can get data that isn't always available in published agricultural census information, or connect us with kind of ministries of agriculture. And so all of this is really only possible because of the incredible work they've been doing for the past 4 decades. So to kind of highlight what our process looks like for collecting all this data, we start with what FuseNet has. Then we use a combination of AI, web searches and Googling and just good old-fashioned kind of luck to identify everything that's available online. So the deep research queries from a lot of the LLMs now have actually done quite good. And so we'll use those for each and every country. We will uh, Google, we will identify the Ministry of Agriculture, Statistical Bureau, all of those in the countries as a first step beyond what Fuse has. Then we look through library collections to find data that has not been digitized yet, including map collections, because if we want to get these boundaries right, sometimes there just aren't records on how administrative units have changed. So we need to go back to like paper maps to identify what shifts happened in the country over the period which we have data. So we found a lot of data through library collections that has not been digitized yet from kind of all over the world. Then, after we do those two steps, we contact ministries of agriculture directly and ask for help filling in the gaps. Uh, by this point, we have a good sense of kind of where our gaps lie, and ministries have generally been pretty helpful in helping us kind of fill out those gaps, which has been very much appreciated. And in cases where we still have gaps, we work with collaborators at CGIAR and IFPRI and other institutions to try and identify data sources or potential contacts who might be able to help us. Okay, so we also try to highly document what we are doing. And one of the things we are excited about is we're producing a country book for each country. And so this country book is sort of a 10 to 20 page document that highlights the nuances of the data collection for each country. So we're not just releasing a table and saying kind of good luck. We're saying this is everything we identified looking at all of these data points here. So this includes nuances in translation. This includes all of the crops. This includes anything we identified as a potential source of data uncertainty to flag. You know, if statistics seem to be less reliable for a particular year than another, we note that in the country book. And so for usage of this data, we've put together kind of an incredible wealth of information you can use alongside it. We also are documenting all of our spatial harmonization methods. So like I said, one of the big factors of this work is making sure we get the spatial component right, that we produce boundary products that allow you to use this data and not just say, here's a table, but really here's data that's ready-made to make a map and compare with other data products. And so we are documenting our full algorithmic design, and we will be releasing all of the files used to produce those boundary products. And I'll get into what those kind of two main boundary products are in a couple slides. We also, I do want to highlight this one. I made it a sub-bullet point, but this represents an incredible amount of work here too that we're hopeful is useful for other fields. So we're recording every administrative change that we find, which in some countries represents thousands of administrative changes. This can be useful for a number of domains from economics to political science, and we'll be releasing kind of all of our records here as well. All our code for our processing and quality assurance will be made publicly available. And we also do light validation. I emphasize light because we don't necessarily know what the ground truth is. Like I mentioned before, we might have disagreement between the national statistics and the subnational. And there's no reason necessarily in every country to believe one over the other a priori. One might end up being a better estimate than the other. So we take the philosophy that releasing whatever data is present with minimal modification is the best approach. And then we allow the user to choose what they would like to do, guided by all of the additional documentation we provide about the nuances we've identified in that country. So I have a very technical diagram on the right showing our spatial harmonization procedure. There are kind of three main things we need to consider when we look at the spatial harmonization for subnational data. And these are merges of subnational units, shown in green, splits, shown in blue, or redistributes, shown in purple. Um, Redistributes are just anything in which the area between two subnational units changes, but there's not necessarily a split or a merge. So this would just be a boundary change. Um, we need to account for all three of these to make sure we provide accurate subnational statistics over time. And so to do so, we're producing two boundary products. One in which we aggregate everything into what we call a stable unit. So our approach here is to just take the exterior boundary of any units that have experienced a change. So for example, the purple units have experienced a change here. We don't know necessarily what happened with that redistribute in absence of a map. So we take the most conservative assumption and just say, this is now our unit. And then we sum up the agricultural statistics in that unit. And so this requires kind of no assumptions, but we do lose some resolution in this approach. So this is kind of be our flagship boundary product just because it requires no assumptions. It should minimize artifacts, even though we're losing spatial resolution here. For ease of use, though, we also are going to put everything on the current modern boundaries of the country. This is going to require weighting schemes. So this will require some assumptions that allow us to distribute the crop area and production onto the modern boundaries. But we will produce these as well, just kind of for ease of use and comparing with other data products. So these are the two data products that HarvestStat will be releasing for every country and for all of our crop statistics. And so just to kind of reiterate, the stable boundary makes no real assumptions. We're taking the most conservative approach, but we do sacrifice resolution. Modern boundary is going to provide us better resolution, but it requires some assumptions to get there. And then, like I said, we're only doing limited validation and quality control. We are going to flag a bunch of things that appear spurious, but we are leaving them in. So we will have a lot of flags for users to do what they wish with the data, but we're not altering the data in any way. We will measure the correlation coefficient, though, with the FAO stat national data to have a sense of where the national data agrees with the subnational data. In a perfect world, they would completely agree in every case. In cases where they don't, we'll make that available so it's clear that there might be more cause for concern in using the subnational data there. And then our last procedure is using NDVI to assess potential year offsets. So that means kind of making plots of crop production over time and seeing if we induce a temporal lag, if we get kind of better correlation with NDVI. If so, then that might suggest that the year we have recorded for the data might be off by one. So for example, the data might have recorded planting year instead of harvest year, and that wasn't necessarily documented. So we use NDVI as kind of a test to see whether we can trust the years as much as we would like to. Yeah, okay, great. So let's get into kind of like the different regional data sets. So the first one is HarvestStat Africa. This measures almost every country in sub-Saharan Africa. And we mostly have administrative one level data, but in some countries we do have an administrative level two. We get a couple decades of records in just about every country. And a lot of them start, pre 2000, which is really exciting to see because a lot of these countries don't necessarily publish, the full agricultural census information. So this is really a testament to the hard work of Hughes. And this was led by Dong Kun Lee and Western Anderson at Maryland and was released earlier this year. And so just to come back to this plot like we saw before, HarvestStat Africa data is what's used on the right to calculate the change in yield. And we can see if we look at each individual country, we get kind of a lot more true resolution looking at changes in yields versus some of the other graded products. So HarvestStat Africa right out of the box enables kind of a big leap in analysis of food security throughout Africa. However, it's important to highlight there is kind of far from perfect correlation with the national data. So on the right here, in the bottom, we are showing the correlation between the 7 major crops and then the FAO stat data. So the correlation coefficient for 7 major crops for each country between the subnational data and the FAO stat data. So if the subnational and national statistics match perfectly, then all of those little squares should read 1.0 and be dark blue. We see a good number of those, but we also see some that are red and negative. The fact we have negative correlation between the subnational statistics and the national statistics is concerning. And so those might be cases in which we should use caution deriving any sort of analysis results from the subnational statistics, because we don't know whether the national or subnational ones are getting us a consistent answer there. So we'll perform this for all of the regional data sets, but just want to highlight that, in going to subnational statistics does not necessarily mean they're better. It just means we're starting to pin down the uncertainty. Okay, so to talk about HarvestStat Asia now, which is the one that is in prep and will be released within the coming months. We are processing and collecting data for 20 countries throughout South and Southeastern Asia. We have pretty extensive data for India, Pakistan, China, Japan, South Korea, and decent data holdings for the rest of the countries as well. We also have lots of new digitized results for many countries. So for example, we've been able to extend kind of the digital holdings that were available for Vietnam by a couple decades. And so a lot of the work here has been going into kind of libraries, digitizing results, and we're excited to make that data available. And so to highlight kind of the current status among these 20 countries in Asia, data collection is finished for around 15 of them. And we are still currently collecting data for Brunei, Bhutan, Nepal, Myanmar, and Cambodia. But we're making good progress there, and we think we're still on track to release the data set within the next few months. So late 2025, early 2026, look out for this data release. Okay, so to highlight what we can do with some of this data, for example, in India, like I said, we've put in a lot of work to kind of catalog thousands of administrative district changes over the past 4 decades, which enables us to put everything on a consistent map. So we can actually make time series plots really easily, all the way back to 1990 when we have district level data. There are other data sources, in particular, ICRSAT, that provide district level information for India. ICRSAT's kind of the gold standard. And so based on the way we've kind of designed our code and everything, we've tried to make it as interoperable as possible with ICRSAT, so that you can take this data and use it kind of as a complement or point of comparison with their work. And so in other countries, we've tried to make this true as well. So For example, with this long time series and looking at everything on a consistent framework, you could look at things like crop migration. So on the right, I'm plotting out how major crops have migrated their centers of production over time. So the circles represent the weighted center of each crop production back in 1966. And the squares represent the current weighted center of crop production. And you can see over time, as agriculture has intensified in India, there's been a lot of shift towards the center of the country, especially as irrigation um, is uh, is employed more extensively throughout the country. Um, so even just plotting out the crops and lets us see kind of cool insights that is not possible at the national level data. We also can start to look at how the nuances of, say, how irrigation affects yield variability. So this is a plot looking at how sorghum grown in the dry season in India has been responding to increased irrigation. So in this plot, green represents decreasing variability in yields, so more stable yields over time. Um, and the orange and yellow represents increasing variability, so less stable yields over time. And then the light green shows us where we have high irrigation. The dark green shows us where we have low irrigation. And in the center of the country, where a lot of the crop uh, production has been migrating, we see that there's decreasing variability across irrigation schemes. And so there's clearly a lot more analysis to be done here, but these sorts of insights are now kind of possible with the subnational data we're providing. We also can look at things like how countries respond to natural disasters. So, for example, Luke Tan, who led the processing of our data in the Philippines, looked at how agriculture responded to Typhoon Yolanda, which hit in 2013. It passed right through this province of Leyte, which we see on the right. And the plot on the right shows coconut anomaly across the country. And we can see directly after the typhoon, there was a huge negative anomaly in coconut production that the province is actually yet to recover from. And so we used our other subnational data throughout Philippines. We checked other tree crops, and we've found pretty significant correlation between production of different types of tree crops and typhoons. And so I got not necessarily like a particularly earth-shattering discovery, but this is the sort of analysis you can conduct in greater detail with the subnational data. And so there's a lot of potential insights that can be derived that were kind of obscured before. And so to kind of highlight the other regions that I mentioned before, so there's HarvestStat Middle East, North Africa, that's led by Philippe Sabo at the EU Joint Research Center. There will be HarvestStat Latin America and Caribbean, led by Rafaela Flash at the Stockholm Environmental Institute. And then we have HarvestStat Central Asia, Europe, North America that will begin after this. So we'll be applying the same procedure to all of these regions. And so if you are like, wow, it's great that there's some national data available for Africa and Asia right now, but I would love to see another country with some national data. We will get to it shortly. And we would love to chat more too. If you'd like to be involved, we are always looking for more people. So let me know if this work is interesting to you. I would just like to conclude by saying if any of this was interesting or you think you'd like to contribute to this work, please reach out to me. We would love to have you join us. We have a huge team, and we've been able to design a framework where the processing we do for each country is pretty replicable. And so we have kind of a good framework going now. So if you think you might be willing to contribute, please feel free to reach out. I would love to chat more about that potential. But yeah, with that, thank you very much. And I would love to take any questions you might have.
Thank you so much, Michael. That was great. I even though that I'm involved, but I'm learning so much actually, and they have questions. I will start with the with the audience for the questions, but then I will come back and harass you.
Sure, it sounds great.
I think we have one question in the comments. If you can access them.
Oh, yes. Has there been a study why irrigation is causing higher yield variability in India? That is a great question. I'm not aware of one, and I will admit that I'm not a expert in any of kind of the scientific regions that I highlighted. I've mainly been leading kind of the data processing, but it'd be great to look into that further. That was kind of the idea here in providing kind of a few science results. These are questions that are open and would be great to explore more with the subnational data available. Oh, and I see a question about the ICRSAT data too. Great question, Chris. So we're using the same data source. Both of us take data from the uh, Ministry of Agriculture. ICRSAT gets it a little bit more directly before the ministry does a lot of their kind of processing. We're just taking the data products that the ministry makes available. And so ICRSAT has done some extra processing and they've extended the data back to 1966. And so they have a pretty remarkable data set. And so ours is meant to be kind of complementary. So it'll be available as kind of a point of comparison using our standardized process. So we can say like this is what our standardized process produces in India, and this is how it can be compared to sort of what is the gold standard that's been used with ICRSAT.
You have another question that was before Chris. Chris, I don't know if you.
Oh yeah, yeah, yeah.
Uh,
How can African do it? Which submit standards? Great question. So with regards to proprietary data, we've tried to be very careful there. So if data is proprietary, we'll make sure to get written permission from any of the ministries of agriculture or whoever possesses that data. So if there are startups that possess proprietary data and they would like to submit it, we would love to chat more and potentially use that data. So yeah, we definitely want to remain respectful of any kind of proprietary agreements. But if you'd like to contribute or you know of data sources that could fit in the database, it'd be great to chat. We will take any data.
um. Yep. So, yeah.
Yes, a great question about the skew in government collected data. We don't take any approach there. We just report the data as we've been able to gather it and say this is kind of what was collected by the government. And so if there are values that look spurious, for example, if there's a huge yield spike one year that we can't attribute to anything else, we will flag that. Or similarly, if there's really low variability, because in some countries we've actually just seen like data reported linearly um, with zero variability, we will also flag that. But we don't toss any data. We don't try and make any assumptions on whether or not data should be included. We just flag it if we think it's uncertain. But yeah, our aim is to just make the data that has been collected by governments available to everyone. Yeah, so we have data on yield, production, and area. Those will be the main ones available in the table. And then we will also release the files that track the changes in administrative units over time. And we will have our main harmonized boundary products that allow you to kind of easily plot this data over time without needing to source a whole bunch of different shape files and try and match names and things. So they'll be kind of it'll be those three data fields, production area and yield, and then boundary products that enable quick temporal analysis. Yeah, great question. So for uh, yet if data does seem to be problematic, but it was reported by the government, we still report it. We say this is the information that's out there. This is the best information we have right now. We will flag it if we consider if we see like any spurious data points, but we leave that up to the user to choose whether or not to include that data. We will sort of include any concerns we have in the documentation, so like in those country books that I mentioned. Um, but in our data releases, we're not actually undertaking any mechanisms to make it better beyond sort of trying to provide an analysis of how it compares with existing national data. To participate in data validation and quality control. That's a great question. We have been sort of growing kind of our workshops and partnerships, and so if there is interest outside of the kind of data collection community, I would love to chat more. We haven't had too many opportunities yet, primarily just due to funding and resource constraints. But yeah, I would love to chat about other potential opportunities. Um, yeah, so the non-digitized physical archives, the digitization, great question. So we do visually check things. We'll use AI mainly as a speed up to avoid typing things in, but we will, ensure that we at least look over the data, make sure that it matches visually with kind of what we see. I will, admit we're not necessarily checking every single value. It's more kind of a visual glance, but we also are then plotting out all of the data and identifying any sort of spurious values. If there's big jumps, big dips, if things look kind of funky in the time series, then we go back to those non-digitized archives first. And then if we confirm that our digitization was correct, that's when we actually flag the data. But it's a great question what role AI can play in validating the numbers and ensuring their accuracy. We've tried using a bit of validation procedures. We haven't found at this stage anything that beats good old-fashioned just people checking. And so we've intentionally introduced like a few errors sometimes to see if people catch them, and generally they do pretty well with the scans we've been doing, but it is admittedly an imperfect process.
Well, I think we have addressed all the questions. I had one question actually. Why, I mean, just why do you stop at the sub level like two, the subnational two?
Mhm.
And what can you like say more about like the use of this data in the remote sensing community? Like what are your ideas? What would be kind of applications?
Yeah, it would be great to go beyond level two. Main reason is time, because we are trying to track all of the administrative unit changes over time so we can present a spatially harmonized um, data set. If we go to administrative level three, that adds an extra layer of processing.
Hmm.
Um, and so that would ultimately be great to do, but that's a pretty significant lift. And so if it's clearly available in a country and they have good records on administrative level three, administrative changes, and the data is available, we do include it. So for example, Fuse has done quite a bit to map the administrative units in Pakistan, and we do have administrative level three data in Pakistan. We publish that because we think why not? But in cases where we don't have that available, it's just time constraints that we've chosen to limit it to administrative level two. But you're right that, going finer and finer would be more and more
Mm,
useful to the remote sensing community.
mm. And they had I don't know if you have mentioned this. Is there an effort to do the same in Europe and like in North America, for example?
Yes,
Mm,
absolutely. Yeah, we've kind of left those till the end, just because the data ecosystem there is a little bit more complete. There are kind of data sets that exist that harmonize kind of more of the data. And so we wanted to address areas where there was more of a data gap kind of waiting to be filled.
mm.
But we will produce sort of a harmonized data set for North America and Europe as well.
Okay. Well, thank you so much, Mike. That was great, actually. So just for the audience, if you want, we will share the recording, and if you want to reach out to Mike, we will share also his contact, and he's very happy to contribute and like collaborate.
Absolutely.
Um, so yes, the recording will be shared after every session. Please fill the form um, that I'm putting in the chat. And the second presentation will be at 10:30. So maybe it's time to have a break and we see you then. It will be more about AI and deep learning using remote sensing. And we will finish by the we will finish today by two sessions, one off with Sergey Skakun that will tell us more about all this product that we're producing in remote sensing and their accuracy and how we validate and how basically how much effort and how much it will take to validate all this data. And then we will do a demo of with the six grain team of how basically we integrate all this type of data, all this source of data in one platform in like operationalized and let's say industrial kind of setting. So thank you so much and see you later. Thank you, Mike. Thank you so much.
Good thing. Thanks,
Thank you.
Floyd. Thanks,
Yeah.
everyone.